today we will talk about bonds, and in that also we will mainly talk about covalent bonds. Okay, so when a bond is formed, if I say an atom is having unpaired electron in its valence shell, and valence shell can have one or more orbitals depending upon the atom. Suppose it is hydrogen, valence shell will be having only one orbital, 1s. It is oxygen, it will be having more than one orbital. So whatever orbitals are, number of orbitals are there in the valence shell, if unpaired electrons are there, then the atom can be reactive and it will be able to form bonds. It wants to form bonds so that it can complete its valence shell. Clear? So whenever a bond is formed, whenever different atoms interact with each other, right, then they do so to complete their valence shell, and it is the unpaired electrons that are involved. So if I say the reactivity of an atom, it arises from the presence of unpaired electrons in one or more orbitals of the atom's valence shell. And when the atoms interact with each other, which electrons are involved? Unpaired electrons. Now, if I say bonds, they can be of different types. Clear? They can be covalent bonds, they can be ionic bonds. This thing depends upon how much is the tendency of that atom to attract the electron toward each other, and that tendency will be electronegativity, and that will decide whether covalent bond is formed or ionic bond is formed. All those things we will see. Okay, so depending on that, the atom can complete its valence shell either by giving its electron to other atom or sharing the electron. All those things we will study. Okay, so let's first discuss about covalent bond. That can be between a non-metal and a non-metal or metalloid. Okay, now if I say, you can see here two atoms A and B. Both of them are having 7 electrons in their valence shells. And how many unpaired electrons? 1 in each. So these electrons are shared between them. Clear? And a covalent bond is formed in which there is sharing of electron pairs. Here this is one pair of electron. Clear? Between the two atoms. And such compounds will be called covalent compounds. Now, how this binding arises? Because of the electrostatic attraction of the nuclei for the electrons. If I say, see, two hydrogen atoms are there. This is suppose electron cloud, and this in the center there is nucleus, and all this is electron cloud, suppose. Clear? Of one hydrogen atom, and this is for second hydrogen atom. Oh, sizes are different. Okay, this is for second hydrogen atom. Suppose again I made one big, one small. You correct by yourself. Okay, so suppose this is also hydrogen, this is also hydrogen. Now when they come close to each other, see the nuclei, the protons in the nuclei will attract the electron of other atom also. Clear? So the electron of each atom is also attracted to the proton in the other nuclei. Suppose this is also hydrogen atom, this is also hydrogen atom. So when two hydrogen atoms come close to each other, they approach each other, then the electron of each atom is also attracted to the proton in other nucleus. Simple. Positive attracts negative of other also here. I am cooking also at the same time. Your people will be like, oh, you. I have a small baby. I have to cook. I have to do everything. I have to upload videos also. Okay. See. So here protons. Two nuclei will be like, okay, they are not attracted. There is repulsion between the protons. In between electrons also there is repulsion, but between proton and electron there is attraction. So if I say this nucleus, this will attract this electron also and its own electron also. If this nucleus, here the protons will attract the other atom's electrons also. Clear? And the binding is because of the electrostatic attraction of the nuclei for the electrons. This results in the formation of bond. This is responsible for holding the atoms together. This is the thing that is bond, covalent bond. Okay. And because of these attractions, the electron becomes shared. Clear? In a covalent bond, forming a covalent molecule. Here, if I say this was hydrogen molecule, when they come close to each other. Clear? The clouds come very close to each other and what's formed? Hydrogen bomb molecule. Okay, a covalent molecule. So here you saw each hydrogen is having one valence electron, and the capacity of this shell and this orbital is of 2 electrons. So first valence shell can have 2 electrons. So these atoms come close to each other and a pair of electrons is shared, and we say a covalent bond is formed and a covalent molecule, hydrogen molecule, is formed, and both the atoms have their completed valence shells. Okay. If I say fluorine atom, you can see it has 5 electrons in its valence shell. 7 electrons in its valence shell. 2 in s orbital and 5 in p orbital here. Okay. See, there are 3 p orbitals. Each orbital has the tendency for 2 electrons. So there are 3 p orbitals, one having just 1 valence electron. Totally in the valence shell there are just 7 valence electrons, and the tendency of the second shell is for 8 electrons. So 2 atoms here, they will come close to each other and definitely attract. The positive will attract negative and the electron pair will be shared, and we get this F2 molecule. Okay. Similarly, water. If you say how is water formed? Oxygen is having how many? 6 electrons in its valence shell. It has a tendency of 8. Hydrogen has 1 electron in its valence shells. So 2 hydrogen atoms come close to 1 oxygen atom, and what is formed? Water. What is formed? Water. Okay. So here this water molecule is a compound made up of more than one type of element. Here 2 elements, hydrogen and oxygen. Okay. Okay. Now if I say what is bonding capacity? Bonding capacity is simply how many covalent bonds an atom can form. Okay. If I say bonding capacity for oxygen, you saw here it can form 2 covalent bonds, 1, 2. But for fluorine, it was forming 1 covalent bond. Clear? Here it was for hydrogen, 1 covalent bond. So the bonding capacity is 2 for oxygen. For oxygen, it is 2. Clear? So number of covalent bonds the atom can form. Number of covalent bonds the atom can form. Okay. So how many valence electrons an atom can share? Simply, the atom can share the valence electron, or if I say an atom can share valence electrons, how many that are helpful in completing the valence shell. So the atom that can share valence electron has a bonding capacity corresponding to the number of covalent bonds that atom can form. Clear? And when the bonds form, then valence shell is completed. Okay. And this bonding capacity is also called the atom's valence, and it is equal to the number of electrons that are required to complete the valence shell. So if I say valence, it is also the number of electrons required to complete the valence shell. Complete the valence shell. Okay. So if I say valence of hydrogen 1, valence of oxygen 2, valence of nitrogen 3, valence of if I say valence of carbon 4. Now here if you see H2, F2, these are pure elements. They are not compounds because they are made up of the same elements. But if I say water, this is a compound. Clear? If you say methane, this is a compound. Methane is the main component of natural gas. This is also a compound. So to complete the valence of carbon, carbon has a valence of 4. It has 4 electrons in its valence shell, and it needs 4 electrons to complete its valence shell. So it has a valence of 4, and it needs 4 hydrogen atoms to complete its valence shell. Clear? Now there can be different types of covalent bonds depending upon the number of bonds shared, number of electrons shared. Clear? Here you can see in water, one pair is shared with hydrogen, one pair is shared between hydrogen and oxygen, one pair again between another hydrogen and oxygen. So there are 2 covalent bonds. If I say carbon dioxide, here 2 pairs of electrons are shared between each carbon and oxygen. So double bonds. Here between 2 nitrogen atoms, 3 pairs are shared. So triple bond. Then there is something called non-polar and polar covalent bonds. In non-polar, the bonding between the electrons shared is C. The electrons are equally shared between 2 atoms. So there is no charges or atoms. Here in polar covalent bond, the electrons involved in bonding, they are unequally shared between 2 atoms. So one that has more electronegativity will attract the electrons more toward itself than the other that has less electronegativity. In HCl, suppose chlorine has more electronegativity, so it is attracting the electrons more towards towards itself, and there is a negative charge on it and positive charge on the other. But this is partial positive charges and negative charges, not complete. So we say delta negative, delta positive. In ionic bond, there is too much difference in electronegativity that the complete electron is taken by the more electronegative atom. Here in sodium chloride, this is, and such a bond will be called ionic bond, that we will study in the next lecture. So what actually is electronegativity? Ability of an atom to attract electrons to itself. A bond is non-polar if the bonded atoms have equal electronegativity. So both will attract with equal love. If the electronegativity of bonded atoms are different, the bond is polarized toward more electronegative atom. So we get partial negative charge denoted by delta negative on more electronegative atom. Oxygen is one of the most electronegative elements. Clear? And delta positive, partial positive charge denoted by delta positive on less electronegative atom. Hydrogen is less electronegative as compared to oxygen. Clear? So in such a covalent bond between oxygen and hydrogen, the electrons spend more time near oxygen nucleus than the hydrogen nucleus. Okay. So, but if I say methane, the bonds are very less polar because electronegativity of carbon and hydrogen is almost similar. There is not much difference. So this is less polar. The bonds here are, these bonds are less polar. Now one more thing. If we have to denote the covalent bonds, the sharing electrons can be represented by dots. Clear? The bonding electrons are a single line also. For example, methane, see, dots, sharing electrons. Clear? So, but they can also be represented by lines here. Clear? Those also indicate, see, single line for single bond, double line for double bond. Clear? Okay. So, if I say, you study Lewis dot structure, right? Lewis dot structure, in which there is the symbol of an element and that is surrounded by the dot that represent the valence electrons. And here see the pair of electron that is shared. Okay, so this is hydrogen molecule, and if we say, we represent like this, this is single bond between the hydrogen molecules. Okay, you can see here the two electron clouds near to each other. They are not attracted by each other. Electron clouds will be there will be repulsive force between them, but the electron cloud is attracted by the nucleus of the other atom. Clear? Then you can see there is a space filling model also. Clear? For water you can see. Then there is ball and stick model. Here these sticks represent the bonds. Okay, so this much was there. Thank you so much.